Hello everyone, welcome back to my channel. For those who are new here, my name is Eduardo and I am an astronomy and physics teacher. In our previous videos, we've been tackling math problems from the IB curriculum, focusing on solving quadratic equations by factorization method. We've started a series dedicated to solving quadratic equations. In the first video, we solved equations of the form ax² plus bx equals 0. In the second video, we worked on equations of the form ax² plus bx plus c equals 0. In this case, with the coefficient a equal to 1. Today, we'll continue solving quadratic equations of the form ax² plus bx plus c, but this time with the coefficient a different from 1. Let's dive in and explore these more complex examples together. Let's start by looking at the equation we need to solve, 9x² minus 12x plus 4 equals 0. Note that here the coefficient a equals to 9. The coefficient b equals to minus 12. And the coefficient c equal to 4. When the coefficient a is different from 1, we have to split the middle coefficient into two terms such that the product of their coefficients is equal to the product of coefficient a times coefficient c. For our equation, the product of coefficient a and c equals to 36. Then we have to split the middle term, minus 12x, into two terms such that the product of their coefficients equal to 36. The numbers are minus 6x minus 6x, because the product of the coefficients minus 6 and minus 6 is equal to 36. Now we can perform as before. Let's group the terms in pairs. 9x² minus 6x plus minus 6x plus 4 equal to 0. We'll factor out the common factor from each pair. The first one is 3x times 3x minus 2. This is the result of 9x² minus 6x divided by 3x. From the second pair, we factor out minus 2. And then divide the minus 6x plus 4 by 2. It gives minus 3x minus 2. Now we see that 3x minus 2 is a common factor of both terms. And then we divide both terms by 3x minus 2, which will give 3x for the first term, minus 2 for the second term. Since both factors are equal, this simplifies to 3x minus 2 squared equal to 0. So this is the factorized form for the equation 9x² minus 12x plus 4 equals 0. And then now we can solve to find the value of x. Taking the square root of both sides, we can write 3x minus 2 equals 0. Then 3x equal to 2. And finally, x equals to 2/3. This is the solution of this equation. Note that for this equation, we have only one solution, x equals 2/3. Now, in a previous video, we saw that the equation x² minus 6x plus 9 equals to 0 was factorized to x minus 3 squared equals 0 and has only one solution, x equals 3. Let's compare this equation with the last one, 9x² minus 12x plus 4 equal to 0, to find an easier way to obtain the factorized form. Let's start by looking at the two equations. In both equations, the first and last terms are perfect squares. For example, in this equation, the first term is a perfect square of x. And the last term, 9, is a perfect square of 3. The middle term, 6x, is twice the product of the square roots of the first and last terms. It means it is 2 times the square root of the first term, which is x, and the square root of the last term, which is 3. Let's check it out for the equation 9x² minus 12x plus 4 equal to 0, which is factorized to 3x minus 2 squared equal to 0. The first term, 9x², is the perfect square of 3x. And the last term, 4, is a perfect square of 2. And the middle term, 12x, is twice the square root of the first term. It means 3x times the square root of the last term, 2. Now look that for both equations, the square root of the first and last terms are present in the factorized form of the equation. It means that when we want to factorize a quadratic equation in which these conditions are present, we can factorize this equation as the square root of the first term, x, in this case x, minus, because the sign of the middle term is minus, the square root of the last term, 3. The same we can do for the equation 9x² minus 12x plus 4 equals 0, because these conditions are satisfied. It means that the factorized form of this equation will be the square root of the first term, 3x, the sign of the middle term, minus, and the square root of the last term, 2. So, when the first and last terms of a quadratic equations are perfect squares, and the middle terms are products of these terms and the number 2, we can easily factorize these equations like this way. Now let's try with another equation. Press pause and try to solve this equation by factorization by yourself. Check first if these conditions are present in this equation. Okay, let's check if the first and last terms are perfect squares. To do that, I have been able to take the square root of the first term and the square root of the last term. Now, if the middle term can be write as twice the product of the square root of the first term with the square root of the last term, we can apply the factorization. So 4x can be written as 2 times x times 2. So twice the square root of the first term and the square root of the last term. So the factorization of this equation will be x, the square root of the first term, plus 2, that is the square root of the last term. And now we can solve this equation. Take the square root of both sides. We can write x plus 2 equals 0. And finally, find the solution of this equation.